Alright, today I wanted to give a little update on these 60-inch small wind turbines from a power standpoint. As you know, over the last few years I've been studying these, collecting data from people that have these and kind of comparing them to what's advertised. Obviously there's a lot of bullshit out there on these wind turbines, and just want to make sure that the truth gets out there so buyers don't get scammed by some of the scam sellers. So one of the other YouTubers, Orlando, who has a channel Orland7S1, and I'll put the link down in the description area for his channel. He's been doing some honest testing on his own wind turbine, which is the Drone, which is a 2.8 meter rotor size turbine, and he recently got one of the 60-inch class turbines given to him for testing. So he had a really good setup and a good wind site, and was able to collect some data. And so I have taken that data and added it into my series on power charts, and we'll see how it compares to what other turbines that we've measured is. So the three that I have compared today is ones that we have some data on. First is the WindMax HY400. It's tested as a 5-blade configuration. It comes with a charge controller, a nose cone, and a hub. It has a slip ring, and it has some very well designed composite blades that have a section on the blade that provides a drag, so it's a quick startup. It's like a bucket shape, just like on this WindBlue one here. It's kind of bucket shaped once the turbine starts spinning, and then it uses the outer section of the blade to create lift, which will allow the RPM to continue to accelerate up. And that's really what you want to have happen ideally, is you want a high RPM as you can, matched with the PMA, to generate the amount of watts into either a batter bank or a grid tie inverter for your situation. This particular unit comes with a controller. It has a dump load built into it. It has a slip ring. It has the nose cone. It's a sealed unit, so you don't have to worry about rain or snow or hail or ice building up inside like you do on some of these car alternator based wind turbines. And it has zero cogging. Cogging is where the PMA itself has a stiffness to it when that prevents it from starting up at the absolute lowest wind speed. You want this shaft of the generator to be able to turn freely without any influence of the magnets against the stator as it's starting to spin up. Second is the WindBlue Breeze, which has been around a long time. These guys are a pretty honest group. They've put a lot of effort engineering into their PMA. It is based on the Delco car alternator case. It does come with a controller. One thing they've done is they've added a stainless steel shaft. If you notice, there are some videos showing up that some of the car alternator PMAs have their shaft will rust out pretty quickly. It comes with some TLG blades. It has a Teflon yaw bearing, so a nice smooth design in the yaw shaft instead of just sitting on a collar. And then it also has zero cogging in its design, which is quite a good accomplishment on their part. And then the one that's been tested recently is this Thermodyne Firebird, which is also hydrogen appliances. Their 1600 watt unit, which is really designed for high wind speed areas. It uses these plastic sword blades using the Hornets, which are very sharp, stiff blades. So they're really meant for high RPM and high wind condition kind of environments, and it has low cogging as opposed to no cogging. So let's take a look at what their power charts look like. So here's my 60-inch class wind turbine power charts using actual data that was collected by users of these on these three turbines. The Firebird is in red down here, which is the most recently collected set of data from Orland, his test scenario. So let's go over that one. You can see that and you can even look at his videos on his channel, and you can be able to extract these same data points. That it doesn't really generate any current flow. until about 12 miles an hour in his setup there, which is a 24-volt battery bank, meaning the turbine has to spin fast enough to generate over 24 volts before any current can start to flow. And that's pretty consistent with what happens with the WinBlue car alternator PMA. It continues up pretty much parallel with the WinBlue. The only reason the WinBlue is a little bit higher is because they have blades that are designed kind of bucket shape, so they can catch a little bit more of the wind than the Firebird can down at these low wind speeds, so it'll perform a little bit better. But at the higher wind speeds, above, in this case, about 28 miles an hour, the Firebird is able to continue on and generate probably higher power than what the WinBlue will be, because the blades on the WinBlue are going to be somewhat limited on how much RPM it can develop, just because it's not aerodynamically as clean as these very sharp Hornet blades, which are really designed to cut through the air at high RPM. And then if we compare those to the WinMax, which we know is designed for very good performance at the low end with this little bucket shape near the root area, and then it has the kind of flying tips on it, so it can actually generate a high RPM at the higher wind speeds and generate a lot more power. The main reason that it can generate so much significantly more power, the PMA itself is really custom built for this application, where these two designs here are all, they're restricted by their size because they're using that Delco case, so they can only put so much copper and so many magnets inside of that thing, compared to what what the WinMax has been able to do with their HY400 design. So there's your three comparisons, and I do think this is pretty realistic. If you look at some of my older videos, I've always been talking about the American Wind Energy Association would be rating these at 11 meters per second, which is about 24.6 miles per hour, and they would be rating them at about 250 watts. Well, guess what? Both the Thermodyne and the WinBlue are coming in right at this measured at about 250. And if you actually look on their data sheets, they actually are advertising something not too far from these tested points. Manufacturers probably have are testing right up at the turbine tower as opposed to down, again, right against the battery bank, so they're kind of advertising a little bit more watts than what's being tested by some of the owners, but if they're not too far off. Now, that being said, what you need to do is watch out for some of these scam sellers. You'll see someone who advertises on eBay who basically has the same design that the Thermodyne does with their Firebird, uses a car alternator, uses the same style blades, but look at the line that they advertise. They're advertising 100 watts delivered at 10 miles an hour, when really this size turbine, the wind itself only has 100 watts available, and it's theoretically impossible to collect 100% of the watts of the wind. At 15 miles an hour, they're advertising over 200 watts. At 20 miles an hour, they're advertising over 400 watts. And at 30 miles an hour, they're advertising 1,000 watts of delivered watts. Well, in each one of these cases, it's 3 times what the Thermodyne turbine that we have been measuring is able to produce. These are the real world customer data, and you know what this line is. So, buyer beware. Alright, that's it for today. Talk to you later.